Hi folks, we're going to take a look at number 4 from the Unit 2 assignment sheet. So they tell us that the value of an Olympic medal goes up by 4.5% in 3 years, and they tell us that the initial value is $21,350. Okay, so in A, what they're looking for is the value of the medal in 10 years, and they tell us that we have to use an exponential model with base E. Okay, so the first thing we're going to do is come up with the model for the value of the medal, and then from there we'll just input 10 to find its value in 10 years. All right, so let's just remind ourselves what an exponential model of base E looks like. I'll use V instead of P since we're talking about value. So the final value is equal to the initial value times E to the KT. Okay, where K is the growth or decay constant. Obviously, we expect it to be a growth constant, so positive here. And again, we're forcing this base to this exponential function to be that number E. All right, so what we have to essentially determine is what this growth constant is. All right, so we're going to use the information given. Okay, so we know that we start off with a value of 21,350. Okay, times E to the K times, well, in 3 years, the value is going to increase by 4.5%. Okay, so initial value, E to the K times whatever time value we're given, in this case here, 3 years, and now the final value is going to be 4.5% more. So how do we determine that? We multiply by 1.045 times the initial value of 21,350. Now notice how I didn't bother to multiply this, because as we've seen in these questions, this number will just reduce on either side of the equation. So what we're left with is 1.045 equals E to the 3K, and that's very easy to solve because we just take the natural log of both sides. So on the left we have ln of 1.045, and then here we've got ln of E to the 3K. ln and E are inverses of each other, so we're just left with 3K. And so K is just equal to ln of 1.045 all over 3. All right, so that means that the model we're going to use for the value of this item is going to be V equals 21,350 times E to the ln 1.045 over 3 times T. And in particular, in A, we want to find the value after 10 years. All right. So I'm just going to input 10 into this equation. All right. So let's do that here. Let's get our calculator out. Okay, so this is actually pretty annoying to put into the calculator altogether. So I think what I'll do is I'll calculate the numerator, the exponent of E first, and then I'll input everything else. Okay, so we've got ln of 1.045, okay, divided by 3. All right, and now I'm going to input the value of 10, so times 10. All right, so now I'm going to take the exponential function base E of that answer. All right, and that gives me 1.158 and multiply it by 21,350. All right, so this is why it's good to really feel comfortable with using the calculator, so you can use all the features instead of having to try to input all this in one step. All right, so here what do we have? We have $24,724.01. Okay, so that's the value after 10 years. Now, the second part of the question, B, asks you how quickly is the value growing at the 10-year mark. Okay, and so what we have to do is we have to essentially translate that into math talk. So how quickly is it growing? Meaning we want to know the rate of change of the value at the 10-year mark. Okay, so in other words, we have to take the derivative of V. Okay, so the first thing I'm going to do is take the derivative of V, and it's a pretty easy one because of this base E. So 21,350 is just a constant times the derivative of this function here. So this is going to be like our u. So the derivative of e to the u is just e to the u. So e to the ln 1.045 over 3, okay, times t. And then we have to multiply that by the derivative of u with respect to t. So in other words, that's just going to be this constant times the derivative of t, which is 1. So ln 1.045 divided by 3. All right, and now we just have to calculate this at the 10-year mark. Okay, so again, I'm going to try to do this nice and carefully here. Now, what I want you to notice is that this portion of the derivative is going to be exactly what I calculated earlier, 21,350 times e to this whole thing times 10. So I'm not going to recalculate that. I've already got that in my calculator. So saves me some time. Otherwise, I'd just have to start over. So this whole thing is equal to this 24,000. Okay, so now I just have to multiply it by what's in the bracket here. So I'm going to multiply that by ln of 1.045, and then I'm going to divide by 3. And there we have $362.76. Okay, but this now is a rate of change. So what does this represent? It represents that after 10 years, the value of this item is increasing at a rate of $362.76 per year. All right. Which, not surprising that it's such a large number, since already it's worth $21,350. So after 10 years, not surprising that the value would be increasing by this much per year. Okay, so just a quick recap here. First of all, make sure you know the setup for an exponential model with base E. Next thing is to use the information given to determine the K value. And then once you have your model, you can solve whatever problems they're asking you to solve. Okay, that's it for this one.